Good morning, all of you. Welcome to the continuation of Matlab fundamentals. In our last session, I have introduced the environmental setup of this Matlab. I have also shown you how to run this Matlab on the browser. So I am continuing with that, right? In our last session, we also discussed these three things: current folder, command window, and workspace. This is current folder, this is workspace, this is command window. Workspace is the space where the variables, you can see the variables that you have created. In command window, you can write commands, you can run those commands and so on. Now we'll see how to create variables in Matlab, right? Different types of variables, and then various other things we'll discuss now. So basically, in Matlab, every variable is a matrix. That means if you create a variable x equals to 3 and enter, if you run this command x equals to 3, that means this is the variable name, this is the value that you are assigning. So you are defining it together, you are defining and initializing together. Now you see we have got a variable here. If you see the size, it was showing it as 1 by 1. Instead of 1, it was showing 1 by 1 because Matlab treats every variable as matrix. That's why even if you create a scalar variable also, it was showing as matrix. The size is 1 by 1 instead of showing it as 1. Right? And then in Matlab, there is no need of defining the data type. It will automatically infer the data type of the variable. Right? In our last class, we also seen that when you run some expression like square root of 25, square root of 25, then the result will be stored in a default variable called answer. Now, if you want to suppress the output, if you want the system to suppress the output, that means let me run square root of 36. It was showing, okay, square root of 36. So you see, it was not showing the output, but still the answer now contain the value 6. So therefore, if you want to suppress the output, you use the semicolon. And there are other uses of this semicolon also, but this is one use. If you want to suppress the output in your command window, use semicolon. Right? Now how to use different types of data types and what are the data types that are supported by this Matlab. So Matlab supports different data types, right? And I already mentioned Matlab does not require any type declaration. There is no need to write the data type of the variable. You can simply write y equals to 10. That's all. There is no need to write whether it is integer, floating point, and so on. Right? So it will automatically infer the data type of the variable and it will allocate some space for the variable. Now what happens when you write y equals to 10.5? It will replace the existing variable. Is it clear? Now let us discuss what are the different types of data types that are available in Matlab. So basically Matlab provides 15 data types, 15 fundamental data types. But all these data types, when you store some value, it will be treated as a matrix. Right? Now we'll see different data types that are available in this Matlab. So Matlab supports different data types such as int with 8-bit integer. You see, you can see here 8 int. When I type int is a int, it was showing all the data types with the name int. So it supports 4 data types with the name int. Int 8. That means it is 8-bit signed integers. Int 16, That means it is 16-bit signed integer. Int 32, 32-bit signed integer. Int 64, 64-bit signed integer. Right? So these are the four versions. Int 8, int 32, int 16, int 8, 16, 32, 64. These are the four data types with integer. Int 8, int 16, int 32, int 64. That means if it is int 8, the largest value is 2 power 8. It is 8-bit, right? 2 power 255. So it is from 0 to 2 power 8 minus 1. If it is 16-bit, it is 0 to 2 power 16 minus 1 and so on. Now let us create a variable y equals to 56. Y was already there. Let me create a variable z equals to 56. When you run this command, it was created as double, right? Z was double by default. Now suppose you want to convert into int, you simply use the command int 8 of z, int 8 of z, and let me store it in z. I want to typecast, that's all, type conversion. Now you see, earlier z was double, now it was converted into int, 8-bit integer. Is it okay? Now let us rewrite the value in z. Let me write it with 566. Let me write it 566. So the moment you entered a value that is more than 255, it was automatically converted into double. Do you see? Right? Now again you can convert into int 16. 16-bit integer also you can convert. Int 16. So you are converting z. Z was, now it was double. You are converting into int 16. Right? Now if you give some value, let us say 567. The value was 567. So these are the four data types, integer data types. Int 8, int 16, int 32, int 64. Now if you want to write some comment, you can write like this, int 8. So it is like, it will not run anything. Int 16, int 32, int 64. So it is a comment. So comment starts with this percentile symbol. That's why it will not display anything. That means it will not run anything. It is like a comment. Right? Similarly, Matlab supports unsigned integers also. So it supports data types called uint 8, uint 16, uint 32, uint 64. So these are unsigned integers. So Matlab supports signed integers, unsigned integers. Signed integers with 8-bit, 16-bit, 32-bit, 64-bit. Similarly, unsigned integers with 8-bit, 32-bit, 64-bit, and 16-bit. Right? Similarly, it supports floating point values also. So Matlab supports two types of floating point values: single precision floating point, double precision floating point values. So the corresponding data types are single and double. Single precision data, double precision data. Matlab also supports character data type. Matlab also supports logical data type. Logical means it is Boolean. Boolean data type it supports. It supports character data type, and it supports various other data types also. These are the basic data types: unsigned integers, signed integers, floating points, characters, logical values, and many more. Now, so these are the different data types that was supported by Matlab. Similarly, it supports this data type called string also. str you can use string also it supports. Now suppose you want to convert from one data type to other data type, you can simply convert. How to convert? Let us say you have a value, let us say where is uint is there? No uint. Let us say you want to convert this y into uint. y, what is the value of y? You can check the value of y, 10.05. If you want to convert into uint 8, you can convert into uint and you can store in y. Now you see 10.5 became 11 because we have converted into uint. That's all. Now if you want to convert into string, let us say I want to convert y into string, you give unrecognized function. It is not int, actually int to string. I should give int to string, integer to string. You can convert. So this is the type conversion, right? This is the way to convert from one data type to other data type. And while defining variables, there is no need to define the data type of the variable. You simply write the name of the variable, you give some value, it will automatically infer the data type of the variables. Now suppose here all the variables are there, workspace contains all the variables. Still you want to see what are the variables that I have created, you can use a command called who. So this who command displays all the variable names you have used. See, so far these are the variable names you have created, that's why it was showing answer x, y and z. Now there is one more command called whose, right? Now if you run this whose command, it will give more information about all these variables. So not just names. Let me run this whose. You see, it was giving the name of the variable, size of the variable, how many bytes it requires, right? And it was in bytes. You see, all are double except y. Y is 8-bit. It is uint 8. That's why it requires 1 byte. Double precision requires 8 bytes. Right? This is the sizes. So this is one more variable. Similarly, we have one more. We have few other commands which will be used regularly in Matlab environment called clear. What this clear will do? This clear will clear the entire workspace. Now if you try to access some variable y, let me create some variable, let me show you the value x. Oh, it is not there, you see. When I am typing, it was not showing this x or y or something because all those variables were cleared from workspace. They were wiped out of workspace. Similarly, now if you want to clear entire command window, there is a command called clc, clear command window. Is it clear? These are the different commands, clc, clear, who, whose, and so on. Right? Now similarly, we can control the output, the way in which the output was printed. Let us say, now let me run a command x equals to 10 plus 7 by 3. Right? Let me run this command. What is the value? We are getting a value x equals to 12.3333. That means by default it was giving the result up to 4 decimal points. Now if you want to change the output, suppose you want to display the output in a different way, right? How to do that one? You can do that using a command called format. So you can change the format of the output. Let us say you want to change the format from format to short. Let me run this command. Now again run the command. X equals to 10 plus 7 by 3. It is format short only. You can change the format and then you can run, right? Or you can change short means by default it was in short. You can change it to long and run. Let me run. X equals to 10 plus 7 by 4. You see, by default it was in short. Short means it will show up to 4 points. If you write long, it will show you up to these many points. So this way you can control the output that was printed also. The output that we are getting can be controlled using this format command. So in addition to this commands that we have seen just now, what are the commands we have seen just now? CLC, clear, whose, right? So Matlab has various other commands also. Suppose you are working with Matlab from your computer, then if you want to change the directory, you can use this CD. Now you see, suppose you want to change the directory to examples, let us say, you can go to examples. You see, you can go like this, you can give. So now you are in examples folder. You see, you went to examples folder, right? So this way you can change the directory also directly. There are some other inbuilt commands like date. If you want to see the date was displayed, right? If you want to see the directories within the folder, these are the directories. Optim, Matlab, and net projects. You see, all these directories were displayed, right? Similarly, if you want to see the path, if you want to see the present working directory, if you want to see the present working directory, you can click on this PWD. All these things you can do. So in our workspace now, what are the things we have? Answer and X. These are the two variables we have so far. Now suppose you want to save your workspace. Now you have done some computation, you want to store the results somewhere. If you want to store the result, you can use a command called save. And you want to store the workspace, then give some file name. So let me give some file name called practice. So I am saving this workspace with the name practice. Now you see it was saved with this practice.mat. Now let me clear everything. Let me clear entire workspace now. Now my workspace was gone. Now will you be able to access these variables? Straight away you won't be able to access. But you already saved the contents of the workspace. So therefore, if you want to access the saved contents of the workspace, we have one more command called load. So using this load, you see practice. Let me load the contents. What is the contents? Practice. I am loading. Now you see again the two variables came here. So these two commands, load and save, they are very useful, right? When you run something, you will get some workspace. Now when you run some other program, your workspace contents will be overwritten. But you want the workspace details to be saved somewhere and you want to access it after some time. Then you can simply save the workspace. When your program is finished, then you can write a command at the end saying that save workspace, right? With some name, save. So it will be saved. Later on you can load that workspace, you can check the values, you can check the results and so on. All these things you can do. So these are important commands. Similarly, we have one more command called what. What is this what? It will display all the files in your folder. So what is the folder in which? The folder in which you are working is R2021B. So in this folder we have a file called practice.mat. What are the current mat files in the current folder? So this is a mat folder. Mat folder means MATLAB file. These are called M files or MATLAB files. We will see all these M files, MATLAB files and so on. So these are some of the commands. So in addition to this, there are many other commands. We'll use those commands as and when required. But these are some of the basic things that one has to know while using the Matlab. So far we have discussed all these things. Now let us go ahead and discuss some of the operations that can be performed on the variables. Now we have seen how to define a variable, right? Now the next thing is, what are the operations that can be performed on these variables? Like all other programming languages, Matlab also supports different types of operators which can be applied on these variables. So Matlab basically supports arithmetic operators. So let me write here. Matlab basically supports. Let me write with this. What is this? Comment. Arithmetic operators. Matlab supports. Relational operators. Matlab supports. Logical operators. It supports. Bitwise operators. It supports. Matrix arithmetic operators. Right? All these operators are supported by Matlab. So arithmetic operators, if you, what are the arithmetic operators? It supports addition, subtraction, multiplication, division. All these operations in it will support anyhow, right? Similarly, it supports power operation also. It supports. That means x power y. If you want, you can. So let me write. It supports addition, subtraction, multiplication, division. And then if you want to write x power something, power operation, exponent operation, this is power. All these operations will be supported by Matlab. These are the arithmetic operations, right? Similarly, if you want to support, if you want to see what are the relational operators, Matlab supports relational operators like x less than y. You want to check the relation between two variables, less than or equals to, greater than or equals to, not equals to, all these operators it supports. Greater than equals to, less than or equals to, not equals to, the symbol is this one, not equals to, and so on, right? Similarly, Matlab supports logical operators, bitwise operators also. Logical operator is friend, logical and, logical or, logical not. So logical operator and or not are this way. This is and, this is or, and this is not, like not equals to not. These are the logical operators, right? Similarly, Matlab support bitwise operators like bitwise and, bitwise or, bitwise, bitwise and, bitwise. So bitwise and, bitwise are same as this logical and logical or. So that means you can use all these operators, arithmetic operators, relational operators, logical operators, bitwise operators. And I will show these matrix arithmetic operators at the time of creating matrices. So far we have not created matrix. At the time of creating matrices, I will show you what are the different matrix arithmetic operations that can be performed on matrices. So let me clear the command window. Let me clear the workspace also. You can clear. Generally we use these commands as and when required, this CLC and clear. So I will stop here. I will continue in our next session.